Fantastic. Five. The government has recently proposed 4 potential sites of special scientific interest, and we are asked to investigate and rank the 4 sites according to the parameters: species richness, species abundance, and biomass of native woody plant species. The survey will last for a year, and we have divided it into wet and dry seasons. Out of each season, 4 days will be selected. We have proposed 2 hypotheses. If we reject the null hypothesis, we will rank the sites according to their differences. 8 people will be divided into 4 subgroups, with each group having 2 members. One of them will measure the diameter of breast height of the woody plants, and the other measuring the height. They will identify and record the number of species. Each site is divided into 50 quadrats, with 0.04 kilometers squared in size. 12 quadrats are randomly selected. This is around 25% of the total number of quadrats. A random number table will be used for selection. To ensure that the 2 seasons are independent from one another, the 4 sampling days from summer and winter will also be randomly selected. Exotic and dead woody plant species will be neglected. We will simply focus on native species with the following criteria. Now, let us welcome our dearest demonstrator. Only plants meeting the aforementioned requirements will be measured. Here, we will need an identification key and a datasheet. She will tag each target individual with a unique number. Next, we will count the number of species and their corresponding abundance. For undetermined species, they will be taken back for identification. By using diameter circumference measuring tape, we only measure plants at a height of 1.3 meters or above, and diameter of breast height greater or equal to 1 centimeter. A tilt compensated laser rangefinder is used, and trigonometry will be applied to calculate the height. After collecting the data, we can now move on to process the biomass through this equation. The estimation considers both the above-ground biomass and the root biomass. To calculate the biodiversity, we will use Simpson's diversity index. The value of D ranges from 0 and 1, 1 representing infinite diversity, and 0, no diversity. We will use one-way ANOVA testing instead of t-testing, because the latter is deemed inaccurate in this sense. The table here shows how we can compute the data to calculate Simpson's diversity index for each quadrat. If the F value exceeds the critical F value, then we proceed to reject HO and conclude that there is a significant difference between the means. Subsequently, we will rank the data using the Tukey test, which can be used to identify the level of significance the means differ from one another. The same procedure will be used to measure the biomass. Several confounding factors have been identified. Natural disturbances, including phenomena such as typhoons, and these cannot be controlled. Anthropogenic impacts include human-induced fires, and the result is self-explanatory. Insignificant seasonality means a slight change in weather patterns between seasons. Hence, we will base the investigation on dry and wet seasons only. The uneven distribution of plants in their natural environment is beyond our control, since we cannot control randomness. The sampling data we collect in a site will differ on different dates. A pilot test can give us an indication of optimum sample sizes for the investigation.